Hello guys and welcome to a new video in physics. In this video, we will talk about lesson 2, which is about conservation of momentum. The focus question for this lesson is, what is recoil and how is it useful? That's what we will learn in this lesson. The new vocabulary that we will learn in this lesson is closed system, isolated system, law of conservation of momentum, and law of conservation of angular momentum. We have a review here from the previous lesson. In previous lesson, we had momentum, and we said that we have a definition for momentum, which is the product of an object's mass and the object's velocity, and measured in kilogram meter over second. This is the definition for the momentum, and we will use it in this lesson. Momentum in a closed isolated system. So in the beginning, we should know what's the difference between a closed system and isolated system. So a system which doesn't gain or lose mass is said to be a closed system. And this is the definition of closed system. But the isolated system, when the net external force on a closed system is zero, so the system is described as an isolated system. So here we have a difference between isolated system and a closed system. If the system doesn't gain or lose any mass, so we can say about it, it's a closed system. But if there's no force acting on a system, so we can say about that it's isolated system. The law of conservation of momentum states that the momentum of any closed isolated system doesn't change. The momentum of any closed isolated system doesn't change. And the law of conservation of momentum is P final equal to P initial. That means the final momentum equal to the first momentum. To make that clear, here we have an example. Here we have two balls, and before collision, let's suppose that their momentum was 10, for example, and after the collision, it should be also 10. So from here we have the law of conservation of momentum, which is P final equal to P initial. Here we have an example about the conservation of momentum, which is in page 224. The example is a 1,875 kilogram car going 23 meter per second rear end. A 1,025 kilogram compact car going 17 meter per second on ice in the same direction. The two cars stick together. How fast do the two attached cars move immediately after the collision? So here we have two cars. The first one, car C, and car D. This is before the collision, and this is the situation after the collision. So before the collision, we had V initial for the car C and V initial for the car D. But after the collision, the car C and the car D moving in the same velocity. So in the beginning, we will write the noun for this question. The noun that we had from the question is 1,875 kilogram. This is the mass for the first car, which is MC, are going 23 meter per second, which is the velocity or the initial velocity for the car C. Here also we have 1,025 kilogram. This is the mass for the second car, which is mass for D. equal to 1025 kilogram. This car, is going on 17 meter per second in the same direction. So we have a positive 17 meter per second. How fast do the two attached cars move immediately after the collision? So we need to find V final after the collision. In the beginning, we said that we have the law, which is P initial equal to P final. And we knew that P initial equal to P initial for the first car plus P initial for the second car equal to P final for the first car plus P final for the second one. In previous lesson, we learned that P equal to mv. So P initial for the car C, we will replace it with mc vc initial plus md vd initial equal to mc vc final plus md vd final. The m here represent the mass and v represent the velocity. In the question, after the collision, we said that the velocity for the first car is equal to the second car, which is equal to v final. So we can write our equation just like this: mc vc initial plus md vd initial equal to mc plus md, all of it multiplied by v final. Because we need to find V final, so we will divide the two sides over MC plus MD. So our equation will be like this. And after that, we will write the number. We have the numbers, we have M for the car C, which is 1875 kilogram, multiplied by the velocity for the first car, which is 23 meter per second, plus the mass of the second car, which is 1025 kilogram, multiplied by 17 meter per second. Also here we have M for C, which is 1875 kilogram plus 1025 kilogram. By using the calculator, our final solution for V final will equal to plus or 21 meter per second. And this is the final solution for this question. Until here, we reached to the end of our lesson. See you in another one, inshallah.